Okay, this is lesson 10.4, and we're going to introduce you to two more tests. One is called the root test, and one is called the ratio test, right? So these, in some opinion, are a little bit easier than the other tests that we've been doing, because these you don't have to come up with the other one that you're comparing it to, the other series that you're comparing it to. So for example, the limit comparison test, you have to figure out which p series you're trying to compare it to. And same thing with the basic comparison test, you have to figure out what geometric or other p series that you're trying to compare it to. Whereas these, the root or the ratio test, kind of tells you what to do. All right, so let's take a quick look. It says that the series of a sub n be a positive term series, and suppose that the limit as n approaches 0 of a sub n plus 1, so the one more term than a sub n, and you will, if you get a limit. Now here's the trick. If the limit is less than 1, it's convergent. So if the limit is smaller than 1, it's convergent. If the limit is greater than 1, apologies for the typo here, just greater, no equal to. If it's greater than 1 or equal to infinity, it is divergent. If it equals to 1, it doesn't tell us anything. So we got to do other tests. It's kind of annoying this way. Okay, so what do we do here? So the first one says, let's see our examples. It's a little bit clearer when we actually can see things in action, right? So the limit as n approaches infinity of a sub n plus 1. So all the n here, you want to do n plus 1 because you want to do one more, right? So you go 3 to the n plus 1 all over n plus 1 factorial. And you want to divide that by your original series here. The original series here was 3 to the n over n factorial. Okay, so then this is a bit more algebra here. So limit as n approaches infinity. This is 3 to the n plus 1. So think about what 3 to the n plus 1 means. It's 3 to the n times another 3. That's where the plus 1 comes from. So that's really 3 to the n times 3. And then the n plus 1 factorial. It's really it's n plus 1 factorial is n plus 1 times n minus 1 times n minus 2 until 1, right? So this is n factorial. So you can break that up into n plus 1 times n factorial, right? And of course, it makes a lot more sense if you want to put numbers in to kind of see that relationship. And don't forget, you're multiplying by the reciprocal, so times n factorial over 3 to the n. Okay, now let's do some cleanup. This actually cleans up really nicely. This reduces out, and you're now left with just limit as n approaches infinity of 3 over n plus 1. Okay, so then let's plug in the infinity. You get 3 over infinity, which gives you a limit of 0. That's okay. Limit of 0, is it less than 1? Yes. So 0 is less than 1. Therefore, this is convergent by the ratio test. Okay. Yeah, isn't that kind of nice? Okay. All right. So, sorry, what is convergent? I want to make sure I'm very clear on that. My 3 to the n over n factorial is convergent by the ratio test. Okay. All right, next example here, you have 3 to the n and then n squared. So let's try to see the same thing again. We're using the ratio test to test this out. So limit as n approaches infinity of 3 to the n plus 1 over n plus 1 squared. And again, don't forget we're dividing this by our original series here of 3 to the n over n squared. Okay, all right, so clean this up. Limit as n approaches infinity. Again, you got to start getting comfortable with this n plus 1, right? So 3 to the n plus 1 is really 3 to the n times 3. N plus 1 squared, we're going to leave it as so. There's not much we can clean this up, right? So then multiply by reciprocal, n squared over 3 to the n. This will reduce out nicely for us. And we're left with limit as n approaches infinity of 3n squared over n plus 1 squared. Now this becomes a higher power polynomial, right? Higher polynomial of 3n squared over n squared if you were to multiply this whole thing out. So the limit would approach 3. Oh, awesome. Now 3, that's bigger than 1, right? So 3 is bigger than 1, hence this is divergent. So my function, my original function of 3 to the n over n squared is divergent by the ratio test. Okay, very nice. All right, one more. This one has a little bit more algebra, so let's be patient and work this out, okay? All right, so limit as n approaches infinity. This is n plus 1 to the n plus 1 over n plus 1 factorial. All right, I'm going to compare that to my original function compare the original function of n to the n over n factorial. Okay, all right, so far so good. So limit as n approaches infinity. This one is n plus 1 to the n plus 1. Okay, now I'm going to break this up just this. It doesn't break up the way you think it breaks up. This is really n plus 1 to the n power times another n plus 1, right? That's where the 1 comes from. So that makes it n plus 1. So this is n plus 1 times n plus 1 to the n power all over. The bottom, the factorial breaks up the same way we knew. So n plus 1 times n factorial. Flip the second one, n factorial, n to the n power. Okay, all right, let's see. Many things clean up nicely in this one. N factorials over n factorial. N plus 1 over n plus 1. All right, so now I have this really cool thing of limit as n approaches infinity of n plus 1 to the n power over n to the n power, right? So now, what do you really have? If you were to kind of clean this up a bit, they both have the same power. They're both to the power of n, right? So I can write this as n plus 1 over n to the n power. Okay, so what is this really? This is really L'Hopital's again, because this is really 1 to the infinity. So that is a L'Hopital situation. So what I do when I have an exponent like that, I have to treat this like a L'Hopital's rule and take set it equal as a function and take the natural log of both sides. So y equals n plus 1 over n to the n power. Natural log of y equals n times natural log of n plus 1 over n, like so. Okay? All right, so now we know then that this gives me a 0 times infinity, or no, infinity times 0, same thing. So you're now taking the limit of that, right? So we know we need to transform that because that is not very helpful to us. But if we transform it into natural log of n plus 1 over n over 1 over n, that will give me natural log of 1, because n plus 1 over n is 1, natural log of 1, which is 0, over 1 over infinity, which is 0. So 0 over 0, great. Now this is L'Hopital's. So I'm going to take L'Hopital's one more time. So limit, well, I didn't take L'Hopital before. I was trying to transform it so I can take the L'Hopital's rule. Okay, good. The derivative of natural log of n plus 1 over n is 1 over the argument of that, which means the reciprocal. So that becomes n over n plus 1 times quotient rule. So quotient rule says, now, either quotient rule or here, there's another way, right? If I can clean that up, n plus 1 over n is really 1 plus 1 over n, or 1 plus n to negative 1. So I think that's a little bit easier to take the derivative of. So chain rule says take the derivative. So like a natural log comes out as this n over n plus 1. And then the inside now is 1 plus n to the negative 1. So the derivative of that is negative 1 over n squared, negative n to negative 2. So negative 1 over n squared. Okay, we have the derivative of the numerator. Now we want the derivative of the denominator. 1 over n on the bottom is really just negative. It's n to negative 1, so it's negative n to the negative 2, so negative 1 over n squared. Awesome, because now these two reduce out. I have a very nice limit as n approaches infinity of n over n plus 1, and that would give me 1. Oh, yes, so we have 1, right? So now it's 1, but wait. I'm like, oh, shoot, right? I'm thinking, oh, 1, what do? This is not good because we don't want 1. But remember, this is why I always mess up too. This is not 1. This is the natural log of y equals that 1. Thank goodness. All right. So natural log of y equals 1. So your limit is really e to the 1, which is e. Oh, that's even better. E is greater than 1, right? E is greater than 1, so there is an answer. That means this is convergent. Okay. So now that means my series to begin with, where is my series? All right, so then that means, therefore, n to the n power over n factorial is convergent by the ratio test. Okay? All right, that's not so bad. Hopefully these 3 examples will give you a good idea. Now, typically, when do we use the ratio test? It is really, really useful when we have factorials. So when we have factorials, this is a very, very useful tool. The power to the n power here, yeah, that's good, but that can also be taken care of by the next one, the next test, which is the root test. So, I think in terms of when you have the nth power and something else, you have a choice. You can use root test or you can use the ratio test. You'll see which one will be easier for you as you do more. But when you have factorial, 99% of the time, you really want to use the ratio test here because it does clean up so much better. Okay. All right. What does the root test say? All right. So it's very much the same thing, that you're basically taking the nth root of your series here and then see if you get a limit of it, right? Take the limit. Take the nth root, take a limit as n approaches infinity, see if you get a limit out of it. If it's less than 1, it's convergent, and again, forgive the typo. If it's greater than 1 or equal to 0, it is divergent. If it is equals to 1, you need to do other testing. Okay, understand that. So what I do here. Okay, so I have this series here. We have this series of n to 3n plus 1 over n to the n. I'm going to take it to the nth root, so 1 over n power. Don't forget, it's a limit as n approaches infinity. Right? Okay. All right. So now I'm going to clean this up. Limit as n approaches infinity. N to the, remember, this is really a power to a power. So you multiply those out. So 3n plus 1 over, times 1 over n is really 3n plus 1 over n. So 3n plus 1 over n, you reduce that out to be 3 plus 1 over n, right? Okay, clean that up. And then the bottom n to the n power, well, the n times 1 over n is just 1. So n to the 1, if you want to write that out. Okay, so far so good. Okay, so now we have, where am I? I'm just going to quickly check something. Oh, yes. All right. So now we have limit as n approaches infinity of this n to the 3 plus 1 over n power over n. Now, really, one thing you want to look at is because n is approaching infinity, right? This is really 0, right? So really you're really looking at limit as n approaches infinity of n cubed over n, right? Which is really limit as n approaches infinity of n squared. Well, then you plug in infinity, you get infinity. Well, it's infinity, right? So it's infinity. So this is divergent by the root test, okay? So you can say infinity is greater than 1, or it is infinity, therefore it is divergent by the root test. Okay, all right, that's it for this one.